Welcome. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. So today we're going to do a review of Chapter 11 and I'm going to answer some questions that were emailed to me. So let's get ready for that. And this is, let's see here, section 11.7, starting with number 21, as we can see over here in WebAssign on the left. It says, in 3 years, 30% of a radioactive element decays. Find its half-life. So we're going to use the half-life formula. A equals A sub 0 times 2 to the negative T over H power. Okay. We know that the time is 3 years. The half-life is what we're trying to find. It says 30% of a radioactive element decays. So at the beginning, we have A sub 0. At the end, we have the result of 30% decaying, which means we have 70% of A sub 0 or 0.7 A sub 0, okay? So the time is 3 years, the half-life we don't know, the beginning amount we just know is the beginning amount, the ending amount is 70% or 0.7 of the beginning amount. So now we get 0.7 A sub 0 equals A sub 0 times 2 to the negative 3 over H power. We're going to divide both sides by A sub 0. We get 0.7 equals 2 to the negative 3 over H power. So now I have a number equals a base to a power. I can change this to a logarithmic equation. Log base 2 of 0.7 equals negative 3 over H. I'm trying to solve for H. And H is in the denominator, but I need it in the numerator. So I'm going to multiply both sides by H. I now have H log base 2 of 0.7 equals negative 3. Okay. I'm going to divide both sides by log base 2 of 0.7. So now I've got H equals negative 3 over log base 2 of 0.7. Using the change of base formula, I've got H equals negative 3 divided by the log of 0.7 over the log of 2. And I'm going to group that whole thing together. Now, putting that into the calculator, negative 3 divided by parentheses, log of 0.7, close that up, divided by log of 2, close that up, close up the whole thing. And I need to put my glasses on so I can see what's going on here. And we get 5.83007463. It says round to 1 decimal place. The 3 would round down. So the half-life is 5.8 years. Okay, now we're going to look at number 23, also from 11.7. And it says, an isotope of lead, 201 Pb, has a half-life of 8.4 hours. How many hours ago was there 70% more of the substance? All right, so again, we're going to use the half-life formula. The half-life is given as 8.4 hours. How many hours ago, so we're going back into the past, was there 70% more of the substance? All right, so time is the unknown. Now, at the end, we have A. In the beginning, we have 70% more than what we had at the end. So this A sub 0 would be A plus 70% of A, which would be A plus 0.7A, which would be 1.7A. So A sub 0, the beginning amount, is 1.7 times the ending amount. All right. So we've got A equals 1.7A times 2 to the negative t over 8.4 power. We'll divide both sides by A, and we'll get 1 equals 1.7 times 2. Actually, you know what? We can do this in less steps. Hang on here. Let's get the eraser out. And we're going to divide both sides by 1.7A. So then on the left, we get 1 over 1.7, and on the right, we get 2 to the negative t over 8.4 power, okay? Now, 1 over 1.7 doesn't come out nicely. You could leave it as a decimal, 1 over 1.7, or you could make it 10 over 17 to clear the fractions. So multiply by 10 over 10, or to clear the decimal. We'll do that, okay? So now it's a number equals a base raised to a power. I'm going to rewrite this as log base 2 of 10/17 equals negative t over 8.4. To solve for t, I'm going to multiply both sides by negative 8.4. So on the left, I get negative 8.4 log base 2 of 10/17. And on the right, I get t. Using the change of base formula, t equals negative 8.4 log of 10/17. That's 10/17 over log of 2. And go to the calculator. Negative 8.4 times the log of 10 divided by 17. Close that up. All divided by the log of 2, close that up. And I get 6.43049, et cetera, et cetera. It says round to one decimal place, the 3 rounds down, so 6.4 hours. Ready? Hang on. Now, let's see here. Going to go back and look at chapter review. Number 8. Okay. So this is the chapter 11 review and problem number 8. Use the table of values of the one-to-one function to complete a table of values for F inverse. Okay. So recall that for a function that's one-to-one, you have the domain and range. Its inverse function, the domain and range would change places. So let's say you've got f, okay, and then f inverse. Here you've got x and y. Over here, they switch. So let's say you had an ordered pair 2, 3 for the function. For the inverse, it would be 3, 2, okay? So f of 2 would equal 3. F inverse of 3 would equal 2. All right. So how's that going to work here? Let's see. Your answer cannot be graded. Use the table of values of a one-to-one function f to complete the table of values for f inverse. Okay. So when x is negative 5, f inverse of x would also be negative 5, okay? Because going from here to here, you'd get negative 5. If x is negative 3, f inverse would be negative 2. because you're going backwards, the inverse function. In other words, okay, let's do this. Let's take this table and write it here. -5, -5, -2, -3, 9, 13, 20, and 5. Okay, now. Oops, that's supposed to be a 5. Okay, so your values are switched, your domain and your range values. So if x is this, you get f of x is that. If x is this, you get f inverse of x, you're going back the other direction. So all these values here are the range of f inverse, but the domain of f. I know that's a little bit tricky. Okay, number 14. Okay. Use composition to show that f of x equals 7 minus 3x and f inverse of x equals negative the quantity x minus 7 over 3 are inverse functions. Simplify your answer completely. Okay. So now, let's see, what are they doing here? They're giving the answer. Okay. So we're going to take f of x, which equals 7 minus 3x, and f inverse of x equals negative the quantity x minus 7 over 3. We're going to compose them in both directions. Recall that if f composed with f inverse of x equals f inverse composed with f of x, if they're equal and they both equal x, that shows that they are inverse functions. All right, so first of all, we want to take f composed with f inverse of x, which is f of f inverse of x. So we've got f of, let's see, the quantity negative the quantity x minus 7 over 3. Now, what the author did, if you're looking over here and wondering where did that come from, we can take this thing and distribute the x and get that, or write it like that, okay? So then f inverse of x would be this. That's going to go in here, okay? And that's going to be 7 minus 3 times the quantity 7 minus x over 3. The 3's reduce, and we get 7 minus 7 plus x, which is x. Okay? So we're halfway there. Now, let's take f inverse composed with f of x. That's equal to f inverse of f of x, which is f inverse of 7 minus 3x, which is 7 minus the quantity 7 minus 3x all over 3, which is 7 minus 7 plus 3x over 3, which is 3x over 3, which is x. So there you go. We've shown it. How fun was that? Okay, and then number, let's see, did I do number 8? Yeah. Number 44. Okay. A wooden statue found in Egypt has a carbon-14 content that is 4/5 of that found in living wood. If the half-life of carbon-14 is 5,700 years, how old is the statue? All right, so again, we're going to use the half-life formula. We know that the half-life is 5,700 years. We want to know the time, so how old the statue is. Now, the wooden statue found in Egypt has a carbon-14 content that is 4/5 of that found in living wood. So the amount found in the living wood was A sub 0. But the statue found a certain amount of time later had 4/5 of that. So that would be 4/5 of A sub 0. Or you could write that as 0.8 A sub 0. Okay? So A would be 0.8 A sub 0 equals A sub 0 times 2 to the negative t over 5,700 power. Divide both sides by A sub 0. 0.8 equals 2 to the negative t over 5,700 power. We now have a number equals a base raised to a power. We can rewrite that as log base 2 of 0.8 equals negative t over 5,700. Multiply both sides by negative 5,700. The 5,700s cross out, the negative and the negative cross out, t equals negative 5,700 log base 2 of 0.8. Using the change of base formula, this would be negative 5,700 log of 0.8 divided by log of 2. Going to the calculator, negative 5,700 times the log of 0.8 divided by the log of 2, and we get 1834.990141. It says round to the nearest 100 years, which would be right there. The 3 would round down, so 1,800 years. A lot of people miss this problem because they don't read the final directions, and so they don't round it to the nearest 100 years. All right, well, that's all the questions I had. Nobody's here. I'm going to call it a day. I'll be back at 1:15 with my office hour, should you have need of me. Tomorrow, no class time. You'll take your Chapter 11 test. And then on Thursday and Friday, I will be here during class time to answer any questions anybody has in terms of reviewing for the final. If you have questions but you can't make the meeting and you want to email them to me ahead of time, I'm happy to do them. Otherwise, have a great day and see you later.